Okay, so PA19 is definitely from the parent survey, and it's coded, yeah, yes, no, if you're retired or not. So, and that one with which other one, Jared?
The other one has H1RE6.
H1RE6, and so it's H1, so it definitely comes from the kid survey, and this is how often have you, how often do you pray? Okay, yeah, I mean, that's perfectly fine to do that. I don't know if you'll find a significant relationship between the two, but yeah, just keep in mind that it looks like how often do you pray is reverse coded. You don't have to recode it or anything, but it is the higher the score, the less you pray. Yeah, so just keep that in mind how that thing is coded. Always like this example of this how often do you pray variable from the kid survey. This thing is coded so that the higher the score means that they pray less often than people with lower scores. So always check to see how things are coded. Sometimes the easiest way to do that is to be in the variable view like we are now, and just look under the values column, and then you can check to see how the thing was coded. Now, if it has lots of levels to it, like the delinquency scale that we made, it's not going to show up like this because it's a variable that has no defined levels of measurement. It's just a completely continuous type variable. And so number of sex partners reported, the delinquency scale. There's a lot of items like that. Number of times used certain drugs in the past 30 days. None of those continuous items will have each one of their levels defined like we see here for the prayer variable.
And then we just go when we're running cross-tab statistics and then chi-squared.
Yeah, so for that example, you use crosstabs, select chi-square. Also make sure though in chi-square that you are doing this, that you go analyze and you go to crosstabs, and that you make sure that you go into cells, and they click you want the row, the column, and the total percentages. Okay. You always want to do that when you run a crosstabs because it's not there by default. They only give you the counts, but you want the percentages too. So you want the row, column, and total. So you always want to do that when you're doing the crosstabs. And then right up here, the top box is the chi-square test itself. You always want to do that. So you know what? I don't know, I'll just.
You want to just copy and paste the chi-square test?
Yeah, the chi-square test and the crosstabs table. For example, the crosstabs, yeah, so I need the, everything that you report on in the questions needs to be represented in the tables. So yeah, I see a reference, I can see where your numbers are coming from.
I'm kind of confused on how to know when to use like each of the tests.
Okay, so chi-square test, the crosstabs analysis where you use chi-square, that is usually done when you have two nominal variables, or when you have variables that have a very limited number of levels to them, like marital status and some other variable that's only 2 or 3 levels. Because what chi-square, the crosstabs table that you use chi-square in, it will produce a table, like if you have a variable, you have 2 variables, one is 2 levels, the other one is 2 levels, it'll produce a variable that has 4 cells in it. It's a 2 by 2 table. But if you have a variable that has like 100 levels to it, you would never want to do that in the crosstab. So crosstab is usually nominal by nominal analysis, or a table that just has 2 variables in it that doesn't have many levels to it, like a variable that's that ranges 1 to 5 and another variable that ranges 1 to 5. That's about as big as you want to get, because that'd be 25 cells in that table that you'd have to look at. So once it gets to approximately continuous variables, like something that's like a Likert type item, then you're probably looking at a test of mean differences rather than a chi-square. That's more likely. If you have a variable that has lots of levels to it, more likely that's depending. You can always recode things and make it work. You can always recode things and make things work in a crosstabs table. Crosstabs table can work so long as variables and it just don't have too many levels. It doesn't really matter if it's a nominal variable or integer. It just can't have too many levels to it. What was the parent variable that you used, Jerry?
PA9.
Oh, okay. I'm just doing a crosstabs example right now. Okay. Oops. I forget to. Let me do that again. Get to check something. Oh, that's why. Doop, doop, doop. Yep, have to have those checked. Okay, yeah, there we get our. Yeah, so this would be a 2 by 1, 2, 3, 4, 5, a 2 by 6 table.
I just copy and pasted all that.
Yeah, that's fine. See, you can do this in chi-square, but you also could do this as a t-test. You could for the t-test, the retired, whether or not the parent is retired, would be your grouping variable, your independent variable, and the dependent variable would be how often do you pray. And because this is an ordinal variable that has 1, 2, 3, 4, 1, 2, 3, 4, 5 levels, not 6 levels, 5, 2 by 5 table, that you could analyze it using a t-test. Because it's the outcome is, it's an ordinal outcome. It's it would make sense to request an average for how often do you pray, as opposed to retired, yes, no. You wouldn't ask for an average for that. You would just want to know what percent is retired and what percent is not.
And you said meeting 12 is like how to do it? I forget what you suggested.
Oh, yeah, meeting 12 on Moodle is our last meeting that we had on Tuesday that shows me going through all 3 of the examples on Moodle. Yeah. Okay. Yeah, I can go over ANOVA here in just a second. Let me, yeah.
I just want to see if you can look at this real quick.
Sure.
So I would like, if one could be like,
Yeah.
I just found that.
Oh, okay, so you have to check. You did what I just did. You forgot to check in cells on the crosstabs. You want to check that you want the total, the row, and the column percentages. Those boxes, check those boxes, and then you'll be able to answer the questions like what percent of parents who are just among parents who are disabled, what percent of their kids are X. Then you'll be
Are we just going off like the questions that we did last week?
Yeah, on Tuesday, yeah. Yeah, it's just those are the template for you, and so you just kind of change the question for you, the
Okay.
question to fit your example.
All right.
You're welcome. Okay, ANOVA. All right, so we can do ANOVA. We can do ANOVA with, we can actually use how often do you pray as the dependent variable in ANOVA, and we can use we'll use marital status as the independent variable, the factor variable. So you'd be trying to address the question, are there differences in average levels of prayer according to the marital status of the kid's family? That's the question you would be posing. And so for ANOVA, this is H1RE6. Okay, so we want to go to where it says analyze. And we want to go down to compare means, because that's what we're doing. We're comparing the means. And then we want to go over to where it says one-way ANOVA.
I can't see the screen.
Oh, you can't?
Now, I think it just loaded. There you go. Sorry.
Oh, okay. Okay, so let me go to analyze, and let me go to compare means, and let me go down to one-way ANOVA. Okay, so the dependent variable, we want it to be, when you do these, one of the kid variables. So how often do you pray? That's the one we'll use. That came from the kid survey. Display variable names and sort alphabetically. And I'm going to go to H1RE6 because that was the variable. We just have to remember that the higher the score on that, that means the less frequent they pray. So we just can't get confused on our interpretation. That's why we always, always, always want to look at this stuff in variable view first, and then probably also run a frequency table on it. I keep skipping over this. It's a short list of the RE, because these are all religion-related questions, H1RE ones are. Okay, so we'll put that over there. So that's the dependent variable. Now our factor variable, that is going to be, we're gonna pick out marital status. We've used that before in the past, but for the ANOVA example, you should be, again, picking from the parent section. So it's all the PA variables. And I'm just gonna make this easy on myself and go right to PA10 because I know what that is. I know that's the marital status of the parent. And then over here, we want to go to where it says post hoc, and we want this, there's all these different tests that compare means, the specific means from different groups to one another. You want to pick the LSD test. That is the test that is most likely to turn up statistically significant differences when you compare means from one group to the next group. Okay, so you want to pick that so you can be able to tell over and above the F test, because the F test will tell us, are there any differences in averages across these groups according to people's marital status or not? The F test does not tell you, okay, where do the differences lie? For that, you need to have the post hoc checked. Lastly, go into options and go ahead and select descriptive statistics, because that will print you the means and the standard deviations for each one of these marital status, the level of prayer for each one of these marital statuses, and go ahead and hit OK. Okay, so you all at home should still be able to see that screen. So here is the results from a one-way ANOVA as we did just a second ago. So we've got the marital.
I only see the variable view data table.
Okay. Let me. Okay. So you see it now?
Yeah, thank you.
Okay. Yeah. So you see here, this is one-way for one-way ANOVA, descriptive stats. Here is how you answer the first part of those questions for the ANOVA, like who has the highest average score, which group has the highest average score, and here it's never single married. But remember the way that thing is coded, the highest, or I'm sorry, the lowest score is here. And so the lowest score means more prayer. And so so single, never married, they are reporting more prayer Then what you see here with the divorce, they are reporting relatively less prayer because the higher the score on that item, the less prayer was being reported. And so yeah, these are just the averages of self-reported prayer for each one of the kids, for the kids from each one of these marital status groups. Okay, the question is, are there any differences overall between these marital status groups? Any statistically significant differences? That is, do the differences between groups and their averages exceed the individual differences in prayer within these marital categories? Because it's not like every kid from a single never married home prays just as much as the next kid from a single never married home. They vary within groups. And so the question is, do the average differences between groups exceed the variation within groups? And it does for some of them, because we can tell that from the significant F. So the F is 6.013, and it's statistically significant because the two-tailed test here, the cutoff, the threshold is 0.05, and that's smaller than 0.05, so the p-value is 0.000. And so we conclude there are statistically different averages in prayer according to the marital status of the family. So it does vary, pray does vary significantly across marital status of the family. And so we come down here and we can say, okay, where are the differences exactly? Okay, and what you see here is you're comparing single never married to married. And so they have significantly different scores. Here you can see right away, because it's star, that means it's significant at least the 0.05 level, and actually the actual p-value level is 0.002 here. So that is a statistically significant difference. And so again, because that variable was reverse coded, the higher the score, the less the prayer, it's saying that kids from single never married homes pray more often on average than kids from married homes. And that's just the actual difference, the one mean subtracted from the other mean. Okay. Yes?
I'm stuck. I can't get off of this one screen, one way ANOVA, like how you carry the variables over.
Okay, I'll come over to you in just a second. Let me finish going through this part right here, but we are just continuing to make our comparison. So here, single and never married compared to widowed, there is no difference. See, there's no asterisk there, and we can look at the significance level. Well, that is greater than 0.05. They're saying there's like almost a 50% chance of committing a type 1 error, is what that is saying, because it's a probability, alpha probability of 0.492, and it can't be any higher than 0.05. And so there's no significant differences between the widowed and the never married. There are between single, never married, and divorced, and again between single, never married, and separated. And so here, and again, the p-value is the significance, two-tailed significance is over here. Here it is for divorced, 0.000, and the p-value for separated is 0.037. But 0.037 is still 0.05 or smaller, below 0.05. And so we'd still conclude that there are statistically significant differences in average self-reported prayer between kids from single never married homes and kids from separated homes. And the kids from the single never married homes are praying more often. And yeah, when we continued through the rest of this table, all that you're doing is just repeating the comparisons. Okay, now you're comparing married to single, never married, widowed, divorced, separated. So there will be some repeats in here. And you'll notice, so see what we're doing here? Single, never married to married, negative 2.449. Married compared to single, positive 0.249, because you're just subtracting now the one with the lower score from the higher score. So that's why you get the same number down here. It's just positive now. It's not it's not negative. You're comparing the same two. You're just flipping who is subtracted from who. And so that's what you got for these post hoc, the comparisons that you get when you check the LSD post hoc. That allows you to answer the question, which groups are different from one another. Okay. Yeah, Amber, what's yours?
I don't know what I did wrong here, but I won't let me click with that.
Oh, because you got more than one dependent variable. The independent variable, PA10 has to go in there with this fact. So take it out of there and then put it down there. Yeah, there you go.
And then okay.
Did you go to post hoc? Okay, you're good. And then you did requesting descriptive stats there. Yeah, okay. And good. Okay. And you should be able to your output. There you go.
Thank you.
You're welcome.
Can you do a t-test too? Or just like go over the steps?
Yeah, so for a t-test, we can do, we'll do, let's see, which one can we do? For t-test, let me find a parenting variable that worked for the t-test.
I just have one quick question about what you just did.
Yeah,
Sorry.
sure.
When I did like the test we just did, the ANOVA, when I had my chart come up, I didn't have any significance, like that little star that comes up. Does that mean that I shouldn't use the two examples I used?
No, you can still use them. You just have to report that they're non-significant. The differences in means are non-significant.
Okay.
That's all you do. You just got to report what it is. Yeah,
Okay.
you don't have to keep mining it until you find significant differences. If you think something is significant and it's not, then it's just like, well, your hypothesis was not supported. You know.
Okay. All right. Thank you.
Yep. Okay. So t-test. Let me find a parenting variable that'd be coded good for a t-test. So I could recode the marital status thing, but I don't want to do that.
I have one more question.
Yes.
So with the ANOVA, the star is showing the significance?
Yeah, but you have to report the p-value itself. So you have to look under where it says sig short for significance, and report what that is, because that says how close you are to committing a type 1 error. Usually it's going to show, if it's significant, it'll probably be like 0.000, but sometimes it's not. Sometimes it's close. Sometimes you're almost above 0.05. The cutoff for significance is 0.05. If it's above 0.05, then you cannot conclude statistical significance, because it's better than a 1 in 20 chance that if you repeat the study, you'll find means that are outside the boundaries of the confidence interval. So that's technically why that's cut off. Why it's a chance of 1 in 20 and not 1 in something else, I don't know. That's just the conventions that statisticians have used.
So then the significance is the p-value?
Yes, significance level or p-value, they mean the same thing. Yeah. Okay, so maybe we'll use this, receiving public assistance, yes or no? Yeah, we'll use this question. PA21 is the grouping variable, and maybe we'll look at prayer again. Okay, so PA21. So PA21 is a decent grouping variable or independent variable for t-test here, because it is from the parent survey and it's coded 0, 1. So it's there are 2 groups of people in this survey according to this question: those who are receiving public assistance and those who are not. And what we want to do then, we want to know, are there any differences in kid outcomes according to parents receiving public assistance or not? Okay, so that again is variable PA21. And so let's go up to where it says analyze. And we'll use that same variable, the prayer variable again, because we can use that for a t-test. We used it as a dependent variable for ANOVA, so we definitely can use it for a t-test. We used it for an ANOVA. PA21, that is our independent variable. So we want to go to compare means for t-test, and we want to go over to where, we want to go over to where it says independent samples t-test is the one you want, because that's the one that compares the means from two different groups or two samples. It's not really two different samples. There's just an assumption that the parents receiving welfare did not have an impact on the kids' scores or each other's scores, so it's independent. Okay, so display variable names and sort alphabetically. So we want to put that PA21 variable into the grouping variable slot, PA21. Oops. Okay, and so we have to define the group. So we have to say, okay, which two are we comparing? What two groups are we comparing? Well, there's only two groups in here. Those coded as 0, not receiving, and those coded as 1 as receiving government assistance. And so do that. And then let's go ahead and do the trying to get, yeah, the H1RE6. Oops, always skipping it. Okay, and again, yeah, this is that prayer variable. So the higher the score means the less prayer. Okay, so you don't have to go into options or anything in independent samples t-test. You just go ahead and you hit OK here, and let me stop sharing this, share. Okay, so here, here is our output for the t-test. So there is a difference in means, 0.203 compared to 0.208, so a slightly higher mean for kids receiving a public assistance, meaning that they pray less, slightly less on average than those kids not receiving public assistance. However, is this a statistically significant difference? It is pretty small after all. Well, turns out we come down here, we want to first examine the F-test, right? The F-test is 1.479, and that is non-significant. So that means that we want to use the first t-value because we don't have sufficient data to suggest that we can reject this null hypothesis and assume equal variance and or not assume equal variances. So we assume equal variances unless this thing is significant. So it's not significant, so we look at the first t-test. If this were significant, we would look at the second t-test down. But we look at the first t-test, and the t-test is only a negative negative 0.723. And is that a statistically significant t-test? No, it is not, because here's the significant, the two-tailed test, and the alpha value is 0.470. And so that is greater than 0.05 for sure. And so there is no evidence here to suggest that frequency of prayer is being impacted by whether or not kids' parents are receiving public assistance. The averages are just too close together.
Can you go back to that little screen where you added the variables. So I'm confused on where you got like the 0 and the 1.
Oh, yes. So on variable view, this is the screen where you toggle down here at the lower left-hand corner. You can go to variable view, and that's what brings this screen up that shows you all the variables listed over here on this left-hand side. And you go over this middle column over here under label, and then I'm sorry, not label, but over here where it says values. And it shows you how the variables were coded if they had specific values assigned to the numbers, so no, yes here. So that's where I got the numbers from for the t-test example I just did.
Okay.
Now you can, for a t-test, you do not have to find a variable that just has 2 levels. You just will be forced to specify what 2 levels of that variable are you using for comparison. So for example, I could have used in that example marital status. I just would have had to pick out the 2 marital status groups I want to be compared for the t-test, because the t-test can only take 2 groups. The ANOVA can take multiple groups.
Okay.
Yeah, but usually you don't want it to, if you have like something like 100 groups, that's probably too much for an ANOVA. You have to rethink how you're doing your groupings. But yeah, if you have a variable that has more than 2 levels to it, but you want to use it in a t-test, you can. You just need to enter into the grouping variable box what 2 groups you want to compare based according to how they were coded in the data. Yeah.
So we're always comparing an independent variable and a dependent variable?
Yeah, so and sometimes it's not obvious. Maybe you can make an argument that one could be dependent at one time, and they could be independent in another case. However, I want you to make the assumption that anything that comes from the parent side is the independent variable, and anything that comes from the kid side is the dependent variable. Now, for the kid stuff, you don't want to use variables that just don't make any sense. Like their gender, their race, ethnicity, things like that are considered completely endogenous variables, like the kids, like the marital status, that's not going to have, that can't plausibly have any effect on demographic characteristics.
Mm-hmm.
So you want it to make it make sense. And so just anything that you may have learned in previous classes or read about regarding parent-child relationships, it could be just like the family structure, like marital status, because I would consider that an independent influence on the kid behavior. And so anything that comes from the parent side, you want to consider that the independent, and then anything that comes from the kid side of the survey, that's the dependent.
Okay.
Yeah. Yes, Brianna.
Can you just see if I'm like reading this wrong when I'm trying to get my numbers?
Oh no, I can check that out.
I changed it from PDA to the exercise to PDA, like 9 times. Alright, so like 942 is the number exercise, right?
Yes.
So what are these percentages right here?
Okay, so this second percentage down, that's the column percent. So among those parents who are not disabled, 16.8% had that response of non-exercise at all. So among not disabled, 16.8% were not at all. Whereas if you look at among parents that were disabled, among those who were disabled, 15.8% said that they exercise not at all.
Okay,
So this is.
I'm getting confused. Like, where's like the kids who exercise?
Is this from the kid survey?
Yeah.
Okay, yeah. So it's just this is, you're looking at whether or not a parent is disabled in relationship to how often the kid exercises.
Yeah.
So I was just saying it wrong. And so that it is. So you're looking at okay. So if you read it column wise down, you would say among parents who are disabled or among those who are not. Second percentage is down. That is the percent among within that group that where the kids are not exercising at all. So so in families where a parent is disabled, 15.8% of the kids say they do not exercise at all. Yeah. The first percentage
And then this, like, does that mean weekly? Is it everyone weekly, like?
no, that wave one, that just means from the wave one survey when they were interviewing when they're 15.
Okay.
Yeah, it's not weekly. It's you to find out that you want to go back to the original survey either on the website or the code book. If you want to find out exactly, but for the purposes of this exercise, I don't think you really have to find that out. It's just the frequency with which they're exercising. But the other thing I wanted to tell you, when you read it row-wise, you can say, okay, among kids who don't exercise at all, 94.7% say they don't have a disabled parent, while 5.3% say that they do. Or their parents report that
Yeah,
they are.
I think I was just like trying to read it like down and across, and I was getting myself confused.
Yeah, and then this is the total percent. So out of the sample, what percent of kids are from homes that do not have a disabled parent and they do not exercise at all? That's 15.9% out of the entire sample.
Okay.
So third percentage down is out the entire sample. The next one up is column, and the first one is the row.
Okay. Yeah. Thank you.
You're welcome. Yeah.
You know, like, two passwords are well, how do I think the right?
Yeah, so that's the grouping variable or the independent variable in your t-test. You just want a variable that doesn't have too many levels to it, so you can specify what two groups, what two levels within that variable you want to have paired. So there's that one I just used was public assistance, but I don't know if you want to use that. If you can use variables that have more than two levels. It just you need to specify.
Yeah. So, okay.
How many? What's that? Okay, member of that. A PTO group. It's like some of those. Let's see.
What else you want, like,
No, this is for a t-test, so it's got to be something that's it would make sense to ask for an average. So if it's coded 0 or 1, you wouldn't ask for an average for that. So it's got to be something that is coded, so it would make sense to say, okay, what is the average score for this variable? So nothing coded 0 or 1, the dependent variable. It's going to have something that's at least ordinal that has, like levels to it. How often you've done something, any of the drug use items, any of the delinquency items, any of those things, how often do you do whatever, any of those questions that ask about lifestyle, those kind of things in there.
Can you see if I'm doing this crosstabs right?
Yeah.
So which one do I put in rows?
It doesn't matter.
Okay. And then I just hit okay.
You have to, you go to statistics and request your chi-square, request that, and then your cells. Go to the cells. Yeah, select row column and total. So you can see the percentages. You find one.
So if I wanted to do a T-table and use marital status for a grouping variable, there's like married, separated, divorced. How would I do the defined groups for that?
Oh, yeah, all you have to do is pick out what two marital status groups you want to compare, look at how they're coded, and pick those two numbers. So I think never married is 1, married is 2. I forget if divorce is 3 or 4. Just you want to look to see how it's coded, and then you want to pick out those two groups based on how they're coded and put those two numbers into the grouping box, and that's how you do it. Does that make sense?
Yeah, thank you.
Yeah, you're welcome.
So when we're running the t-test, is it independent sample t-test we put on?
Yes.
And how do we tell which ones are test variables? I think we already have a variable. We just put,
That's the dependent variable, so that's the kid variable.
okay, so then the grouping would be our PA one.
Yes.
You know, we have to define the groups.
Yeah, it depends on how that grouping variable was measured. So you have to look back to see how it was measured, and then plug those values in.
So I'm looking at the tables right now.
We're up
Yeah, the so
yeah, it's good. Yeah, so 0, 1.
the way 0, 1 is all.
Yeah, that's what counts. So those are the two groups that you would be comparing.
Is there an easier way when you're like trying to find stuff on the sidebar to like put into like test variable? Is there an easier way to find which one? Because I've been looking for the same one for like 2 minutes and I can't find it.
In what screen are you in?
Like I can't share because I'm on a different computer, but like when I go to independent samples t-test and I have like the test variable and the grouping variable, is there like is easier way to find what I'm looking for? Because I can't find it. I looked at it in the test, like yeah, right here. Is there an easier way to find it?
Which variable? I can help you. Which one are you looking for?
I'm looking for H1DS12.
Oh, okay.
I've been scrolling the whole time.
Wait, this is alphabetical. Yeah, that's one of the delinquency items. Oops. It's right there.
All on the top. Okay.
Yeah, I mean, yeah, just make sure you're sorted alphabetically. That helps me, because otherwise it's by the file order.
Okay, thank you.
You're welcome.
So my variable, my child variable, so it's way it's measured with none of the time, some of the time, half the time, most of the time, all the time. I will use that for t-test.
For what variable?
The H1C on that, how often do you time, some of the time, half the time, but regularly.
Yeah, you can. You just, that's probably only asked of a subset of the population. It's fine, you go ahead and use it. Just, you're gonna probably have only the 25% of the sample who was non-virgin answering that question. But that should go without saying.
I would think, unless the condoms are being used for different purposes.
Yes.
Can you help me read this?
Mm-hmm.
So I'm stuck on this one. So these two. So when I go up, that would be yes, right?
How many
That would
kids
be
are from
this number?
divorced homes? 824.
Oh,
It's
okay.
over here. Now, how many kids, total in the sample? That's 824.
Okay, so I guess what I'm hung up on is the yes or no.
Okay, so that's the number of kids from divorced homes who are no in this column, who are no for that. Here's the number of kids who are yes for that.
Gotcha.
That are all from
total.
divorced homes, and that's just the total number of divorced kids. Because there's the total margin on the far right-hand side, and there's one at the bottom for the columns.
Mhm.
So there's the three sets of percentages in there too. There's the row percent, the total percent. I mean the row percent, the column percent, the total percent.
And then for the percent, that would be the same thing.
Which question? Depends on how the question is phrased.
What percent of kids are from divorced homes?
Yeah. So that's the total number.
So that would be this.
It would be 14.7%.
Okay.
Or see, this is within this whole divorce, so that's 14.7% out of the sample are from divorced homes.
Okay.
So out of the whatever 6,504, that's the percent they're from divorced homes.
So these two, this is one of the variables we get. And then this one is this, right? Or am I confusing it?
This is the marital status variable, yeah. I think we did a recode exercise where we put separated and divorced together and collapsed them into one category and used that as a new variable. We did that as an exercise. But this is just, you're looking at, this is one variable here, and then you're yes. What do you have for the other variable? I don't scroll up. Oh, smoke a cigarette.
Yeah.
Oh, so yeah, this is just the one we did.
So then, and that's part of the assignment, right?
That's class exercise.
Oh, okay.
Yeah, that was just exercise that you can see us doing that in meeting 12.
Gotcha.
Yeah, the assignment is you come up with your own test.
How many questions do you want answered on like each table?
Well, it should be equivalent to what I had in the exercises. So you don't have to do more than that, just, because you could put more questions for the chi-square table. You could have tons of questions for that, but you don't need to do any more than the number I did.
Can I like just put the output file, like attach it to the assignment for the t-test? Because when I try to copy and paste it into Word, it cuts off the chart, and I can't figure out how to have it not do that.
Yeah, I don't want any extra files in there. You can, let's see, I'm wondering what the problem is. So what, for the t-test here?
Yeah, it's only for the part, like the group statistics goes like in fine, but it's the independent samples t-test. It like cuts the chart off.
Yeah. Yes.
If you click on in the word, it'll come up and it can say like,
Because, yeah,
right click it, you can do auto fit, and you do auto fit the window.
okay.
It'll fit in the word.
Okay, thank you, Christy. Let's see, right click, and then what is it?
You gotta copy and paste it in the word first.
Oh, okay, so yeah, copy, and here I'm gonna go to Word, and, because yeah, you can paste it special. If you paste it as a picture, then you can manipulate it, you can shrink it down.
Okay.
So you can try that, or what was the other way? So, oops, what was that? Now, Christy, what did you do here? You had it.
So I pasted it with the paste options, the one that has the brush and stuff.
Yeah.
And then when you do that, it'll come up with the chart, and then they'll have like a little cross and a square up in the left-hand corner of the chart. If you right click on that and go to auto fit, you can auto fit to the window.
I was able to get it as like if I copied it as an image, I was able to put it in Word and
Okay. Okay. Yeah. I'm just
Thank
seeing.
you.
Oh, yeah, you're welcome. Just try. Why is this weird thing keep coming up on my screen? I don't know what that's all about.
I think my document might be a little bit too long to get the Google just because of the charts. So if that's the case, I'd be able to share, with you.
Too long to submit because of the charts.
Whenever, like, when I did it on Google Drive, so I like copy and pasted everything into it. And then like I'll try and submit it on Google sometimes with SPSS. This happened last semester. And it said that the document was too big.
Oh, well, let me make sure that that's, because I can change a setting on here. Let me. Yeah, okay, well, it's set at the maximum file size and can be submitted. 64, I don't know.
It's not 30 yet. I'm just doing my last test right now. I'm at 11 pages. Because they take up a lot.
Okay.
We'll run one more example. Go ahead and know the test.
Yeah, I mean, I've got this screen right here for ANOVA. You want me to go through the procedures again?
Yes. Yes.
Okay. All right, so for an ANOVA, we want to go to analyze, we go to compare means, and we want to go to where it says one-way ANOVA. And what I used here was this variable PA10 for the factor, because that's the independent variable. I put that in there. That has more than two groups, and it's a parent variable. So we use that as the factor of the independent variable. The dependent variable, we used prayer. I can switch that out and I'll do something else from the kids survey. Just do, let's see, we'll say, maybe just the general health item. Yeah, general health item. Okay, so for the dependent variable for this, you want to have something that, like t-test, it have to make sense to ask for an average. And so this is that, how is your health? That general question about health. And so that was scored, I think, like 1 to 5. It's reverse coded though, so the higher the score, that means the worst health. And so you just want something, some item like that that's would make sense to ask for an average for it. And if that's the case, then it's worse for ANOVA. So for post hoc, you want to have the LSD one checked. So that's going to allow you to compare the means of individual groups. And then for options, you want to have descriptive stats checked, because then it's going to give you your descriptive stats, your means for each one of your marital status groups. And we hit OK. Oops. So here is the example looking at marital status and self-reported general health. And there are some differences in averages. Looks like the highest scores, which in this case would be the worst health, being reported by kids from separated homes. The best health is being reported by kids from married homes. And there's some other differences here, but the question is that are any of these means different from one another beyond what we'd expect at random? And the answer to that is yes. The F is 9.615, and that's statistically significant. The alpha value for that is statistically significant, 0.000, so it's less than 0.05. So there are differences in the averages across marital status and self-reported health. Where do the differences lie? Well, if we start with, looks like married has the lowest score, which in this case is the best health. And so if you compare married to single married, or to single or never married, there's not a significant difference there, because, well, this is not starred, and also this significance level, this alpha value is 0.239, so that's above a 0.05, so that's not significant. However, married and widowed, there's a significant difference. So there's better health being reported by married kids from married homes than widowed homes. There's the alpha value, or 0.003. There's a difference again between married and divorced here. And here's the alpha value. And then there's also a difference between married and separated. So in each case, marrieds, because this is negative, the marrieds are scoring lower than the comparison group. And to score lower on this general health item is actually a good thing, because that means you're self-reporting better health. Okay, and so this is just repeating for all other possible comparisons, and there is some redundant information in the table. So.
How do you know when to use a t-test versus when to use an ANOVA test?
A t-test should only be used if you're comparing two groups, no more than two groups. If you're comparing more than two groups, then it's an ANOVA. And if the dependent variable is something that's coded so that it would make sense to ask for an average. So you don't want to use an ANOVA or a t-test if the dependent variable is coded 0, 1. it's going to be something that is an item that ranges from like 1 to 5, or delinquency 0 to 45, or something like that. That it would make sense to ask for what the average score is, and then you can, if you have just 2 groups, then that you're comparing scores, it's a t-test. More than 2 groups, it's an ANOVA.
For a t-test, when it's asking, like on the Moodle, it says like, G, what is a significance level p-value? Where would I look to get it on the t-test?
So for the t-test, let me go up to the t-test example that we have here. So here for this t-test, we looked at receiving public assistance and frequency of prayer. And so the t-values are right here. The significance values for the t-tests are right here, where it says significance two-tailed. Yeah, and so first, the process here is we look at the F, and we notice the F is not significant, so that means that we can assume variances are equal, so we can just look at the first t value, and it's non-significant. So is the other t value. Usually if one t is significant, so will the other one. Usually the differences in how the t's are calculated doesn't make much of a difference. But yeah, in this case, your significance level, or your alpha, is 0.470. And so that's not significant because it's bigger, it's greater than 0.05.
And then for p-value, where would that?
The significance level or p-value is the same thing.
Oh, okay.
This is the actual t-test score. So the t-test itself is negative 0.723, but the significance level or p-value is 0.470.
Okay, because my t is 0.500, and then my significance is 0.617 for like the one I did.
Uh-huh.
So how would I know if that's significant?
It's not, because your significance value is well above 0.05.
Okay, got it.
Yeah, if it's above 0.05, then if your significance test, the two-tailed test, is above a 0.05, then you can't conclude statistical significance. Yeah, t-values don't start becoming significant until you get up to at least a 1.9 something positive, or a negative 1.9 something. This t is like a z-score, in the sense that a 0 means there's no differences, and then you can go go to infinity on the negative side, and it goes to infinity on the positive side. So the raw t-scores are not bounded by any particular range, but a 0 means basically there are no differences at all between mean scores. Okay, folks, I'm going to have to get out of here in just a couple minutes. Are there any other questions on this before I walk to go get my son to school? Any other questions here, folks?
Can you just, before you leave, can you check to make sure? So I use the parent variable, level of education, and then serious physical fight for the dependent variable.
Okay.
But there's like a million columns. Is that still fine? Like it's not, I guess I'm comparing the one, like see how there's all of these? It's not like a yes, no. Do you know what I mean?
Yeah, well, that may not be one you want to use for chi-square. So I said for chi-squares, don't use ones that have too many levels to them. Like you want to keep it so a variable has only 2 levels and another one has 3 levels.
Okay.
That is this is level of parent education.
Yeah.
So for that one, you could maybe use it as an ANOVA.
Okay.
Maybe that you use that as the factor variable for an ANOVA. You could also recode it to see if there's being differences between the certain parameters. You could use this also for a t-test. You could say, I want to test between the parents who have less than 8th grade education and those who have college degrees. You could do that too. Or you could just throw the whole thing in ANOVA and say, that is my factor variable. I want to know if there's any average differences in physical violence according to the parents' levels of education. So you can do that in ANOVA.
All right, thank you.
You're welcome.
Okay, folks, here I'm going to go ahead and sign off. So if there are any simple questions, you can email me. But yeah, this assignment is due next week. So I will see you then on Tuesday. What we're going to do on Tuesday is we'll continue on with this material, and we should be reading should be at least on chapter 15 in Babby. So that's what we should be at in the main book. Graduate students should be reading that Legacy is a Crime book at this point. They should be starting reading that. I'll send out a notice about that. But okay, that's all for today, folks. I'm gonna let you go. Bye-bye. Take care. I will see you again soon.